This lecture is about our salivary glands. Okay, our salivary glands. We will see there are three bigger paired salivary glands on either side, and in addition there are many more minor, even very small, singular salivary glands spread all over the oral mucosa. They are found at the inner side of the lips, the cheek, and the palate, even on the tongue. To start with, we first will speak about the macroscopic anatomical situation, and then I will briefly explain how these glands are formed prior to birth, and then we will look at typical histological structures of these glands. There is one peculiarity which is even hard to believe, and it is true though. The longer the path of saliva from the gland to the oral cavity is, the thinner the consistency of the saliva, and the salivary glands with the shortest excretory duct have the most viscous saliva. Of course, you will find all the contents I address in this lecture in pictures and words in my textbook Oral Structure and Biology, and also in our atlas, The Face. That is why I always include the page numbers in the upper left corner for reference. And there are some other very good textbooks where you can deepen your knowledge. There is a complete textbook by Andreas Filippi just about saliva. And there are other textbooks, the classics by Berkowitz and by Garant, shown on the right. There are three paired salivary glands. We have the parotid gland on either side, back at the cheeks, close to the ears. And then the submandibular gland, embedded in the lower jaw. And then we have the sublingual gland directly below the tongue, again on either side. In addition, there are an abundance of small single salivary glands spread all over within the oral cavity. Let us begin with the parotid gland. It is located, as the name indicated, next to the ear, or more precise, anterior to the ear. And there is a superficial part which lies on the masseter muscle. And you can even feel it yourself if you palpate with your fingers here at the angle of your mandible. And further posteriorly, it covers the ramus of the mandible and it extends even further back. And in addition, there is the deep portion, which extends deep into the retromandibular groove, and it may approach the styloid process. You see it here very nicely in the sagittal section, and also here in the horizontal section. It becomes nicely clear how the glandular tissue behind the ramus of the mandible is located. And in the right image, in the more cranial section plane, this can also be seen. And very close to the parotid gland, we find the external carotid artery, and the retromandibular vein even runs in the middle of the gland. And the facial nerve passes right through the center of the parotid gland. In the glandular tissue, it branches off to form the parotid plexus. This becomes particularly problematic when a tumor of the salivary gland affects the nerve plexus or when surgical intervention is required. The excretory duct of the parotid glands extends fairly horizontally in anterior direction and then curves medially around the anterior margin of the masseter muscle. And glandular tissue lying on the parotid duct is called the accessory parotid gland. And the parotid duct is also called the stenonian duct, and there are many proper names for it. Anyway, it passes through the buccinator muscle and opens on the inner side of the cheek, buccally from the second upper molar. The parotid gland is supplied by the external carotid artery, the maxillary artery, and branches of the superficial temporal artery and a transverse facial artery. They, of course, also pass through the gland and continue upwards. And this is also true for the retromandibular vein, which then flows into the external jugular vein. And the lymph drainage of the gland is facilitated via the superficial cervical lymph nodes. The submandibular gland lies in the submandibular triangle at the dorsal edge of the mylohyoid muscle. So one part is hanging underneath the muscle, you can see here in the picture, and then it goes up over the posterior border of the mylohyoid muscle, where a part of the submandibular gland also lies on top of the mylohyoid muscle. In the frontal section, you can see it again. One part underneath of the mylohyoid muscle and the other part above. And the excretory duct extends even further anteriorly under the mucosa of the floor of the mouth, above the mylohyoid muscle and medially from the sublingual gland. The excretory duct is also called Wharton's duct. It then has its opening to the oral cavity at the sublingual caruncle. The blood supply comes from the facial artery. We have seen this image earlier, but now we are looking particularly at the sublingual gland. It lies on the mylohyoid muscle, easily palpable through the thin mucosa on the floor of the mouth. The gland extends further anteriorly, medially of the mandibular bone, and also in the frontal section it can be seen very well how it is located underneath the tongue. It is composed of about 50 individual small glands, each with its own small excretory duct, individually called minor sublingual ducts, and further forward there is also a major sublingual duct near the caruncle, and the blood supply comes from the sublingual artery. In addition to these large glands we have just discussed, there are also these many small individual glands. They are located in the oral mucosa and can be found everywhere in the oral cavity. Here in the pictures, on the insides of the upper and lower lips and on the palate. They can also be found on the cheek mucosa and even on the tongue, as clearing glands on the back of the tongue. So now I try to sketch it for you on the board how the prenatal development of the glands is coming about. So it starts with the oral cavity epithelium that thickens at a certain point, don't ask me why and where, and then this thickening gets longer and longer and it goes down into the mesenchymal tissue, and then its end, it forms the end pieces, and the sprouting epithelium forms like end pieces like this. It is all embedded into a very coarse capsule of mesenchymal tissue which has condensed, and also some septa have been formed that are in between these lobules. And of course there's a lot of blood supply. I just indicate this here by some arteries, and you can also have some veins, of course, the blood must go backwards also. And not to forget the nerves, because it must be controlled how the saliva is being produced. And then there's one peculiarity. We have this at the beginning. These ducts are compactly filled with epithelium. There is not at all any passing through. But only later then, the center of the duct sort of clears up, forms a tube. This is done by cell death, apoptosis, and also some shifting of the epithelium in order to form a pipe-like structure, which is the duct, which then allows this saliva, which is produced down here, to be given up down there into the oral cavity. Saliva is very important. We notice this when our mouths are really dry. There is also the clinical condition of xerostomia, dry mouth, which is really very unpleasant. This may have many causes, including side effects of medications that affect the water balance of the body in general, such as diuretics. But we also have to take into account many other internistic correlations in the patient. So water is a major component of saliva and mucins, mucus-forming proteins. And then a lot of antibacterially active lysosomes are present, and also fungicidal and antiviral. And even anti-cancerogenic proteins are found. And we know that digestion starts in the mouth. That's what digestive enzymes like alpha amylase and lipases are doing. And ions serve to buffer the pH, which is kept between 6.5 and 6.9 in the mouth. And of course, saliva serves to remineralize tooth enamel, for which it contains calcium phosphate. And saliva even has analgesic effects, and it promotes wound healing. Now we know why people say that they lick their wounds. It seems to be old knowledge in mankind. And finally, we can still extract a variety of biomarkers from saliva for diagnostic purposes and for forensic medicine. Although the salivary glands have a basically identical structure design, which I will show again later in a schematic diagram, they differ in terms of their saliva production. For this purpose, the parotid gland has such serous end pieces marked in the picture above on the left, which produce mainly serous saliva. And the further details which we see here in the histological picture, I still explain in the schematic picture towards the end of this lecture. In the submandibular gland, we find a mixture of serous end pieces, which are a little darker, and mucous end pieces, which can be recognized by their lighter content. And you also see a lot of mucous end pieces with serous end caps on them. So what is being produced here is a mixed saliva, a mixture of serous and mucous saliva. And the sublingual gland shows almost only light glandular parts. There is the mucous saliva in the end pieces. It is fascinating how we find this in nature. The gland that has the longest path to the oral cavity, this is the parotid gland, produces the saliva that is most flowable, the serous saliva. And the gland that lies directly under the floor of the mouth, the sublingual gland, with the shortest excretory ducts, that produces the most viscous, the most mucous saliva. And anatomically, in between, is the submandibular gland, and that shows a mixture of serous and mucous production sites for the saliva, which is then just seromucous. Why is it so? I cannot explain, but we can at least remember it very easily, isn't it? As we said at the beginning, in addition to these three large paired salivary glands, there are many other small individual salivary glands spread all over the oral cavity. They are located in the submucosa. They have only a very short excretory duct and only a few or even one glandular lobe. And here, as an example, you see the buccal glands. In this histological section on the left, you can see the skin of the cheek with the hair follicles and the sweat glands. And on the upper right, the oral cavity is cut, and then opposite to it, you can see a buccal gland with its excretory duct. And in a similar form, there are the labial glands on the inner side of the lips. In addition, molar glands are distinguished opposite to the molars. And on the palate, there are the palatal glands, and on the tongue are the lingual glands. These are all predominantly mucous or mixed seromucous glands. And then there are purely serous secreting glands on the back of the tongue. Finally, let's take another look at the general structure of a salivary gland in schematic form. What you don't see, that is what I left out of this drawing right here, is the connective tissue capsule of the gland, the interlobular connective tissue, and some fat cells, which you sometimes also find in the glands. But on the right, you can see the epithelial main excretory duct and stretches with striated cells of the duct. These are specially constructed stretches of cells where electrolyte exchange takes place. And nothing happens in the junctional, the intercalated parts of the duct. These are just the connections to the serous demilunes shown in pink. Here serous saliva is produced. And in the mucous, tabular, secretory end pieces, intercalated or striated ducts are often very short, maybe even absent. And in the mixed glands, the mucous, tubular, secretory end pieces bear numerous serous demilunes, but serous pieces are also present. And schematically, I've also indicated the innervation. The salivary glands are innervated parasympathetical and sympathetically, and in their function, and of course also sensory. And salivary glands are also well supplied with blood. That's clear actually, isn't it? Because the saliva must be produced somehow, and the substrates, they come from the blood. So now we come to our take-home message. There are three pairs of large salivary glands: the parotid gland, which produces predominantly serous saliva, and the submandibular gland as a seromucous gland, and the sublingual gland with its rather mucous saliva. And not to forget, there are also the many individual glands with very different types of secretion. And with this, I thank you for your kind attention.